So good morning again. Now is in the recording. Um, the exercise you did yesterday, just discussing the architecture of the system without entering into details, but just trying to depict the components and the connection between components of a real problem. Yesterday we have discussed how uh, to write how to design a simple process, which is in jargon is called a stay alive. So monitoring process able uh, to know if all process involved in an automation systems are running, or if for some um, non-predicted reason, the problem, the old system was deadlocked in some way. And the purpose is to discover this, and in that case, to provide putting the system in a safe state, as to say, uh, making all processes exiting and bootstrapping again, or in any case, the idea of stopping everything for safety. That this is a really relevant and significant uh, problem. In real systems, this is carried out, just to know that, at two levels. Usually there is one process like the one we have tried to sketch yesterday, um, that uh, measures the capability of all processes to compute and to detect if there is a deadlock, or in more complex cases, starvation. But sometimes there is also, sometimes in critical systems, there is also an external device, a timer, that is implemented in a completely different and separate computer. Usually it's a microprocessor, because the computing power required is very small, that simply executes a periodic loop, sending interrupts to the your application process, the concurrent process, and also to the operating system itself, because in some rare cases also the operating system may fail. Consider some critical situation like an airplane, or um, some situation in which a failure on the system may be absolutely dramatic, so must be discovered immediately. And the idea is that there is an external processor, external because we must be sure that it always runs, and if the normal processor devoted to computing as a failure, this processor that is called timer, stay alive timer, or watchdog timer, you're guaranteed that it always runs, and simply it sends interrupts to the main processor. Considering that if the main processor reacts to interrupts, in our cases signals, um, there's no general failure. In case of the main system does not answer to signals, in that case, the watchdog timer is able externally to stop the main processor and put the system in a safe state. So the idea of processes, or logical processes inside the system or outside, able to detect the deadlocks of any kind is very important in real application, particularly in critical applications in which a failure can be dangerous. So this was the first, the sketch of the first problem. The second problem was the idea of how to use signals to schedule processes, as to say, to activate using some schedule policy. And for simplicity, even if it is just an exercise, because it's pretty unusual to do that, but the idea is was to try to implement um, the scheduling policy that we know, you must know, that is the basic round robin scheduling policy in Unix and Linux. So I think they are important exercises in which the aim is just to sketch with a picture, with some drawing, with arrows, with some scheme, the components and how to connect them, and which is the main logic for the interaction between subsystems. And today we will do a further exercise related to the mobile robot model that we have sketched in the first classes. So it's more like, more or less similar to our general aim. Let me say that these exercises are very important, even if they may seem just an occasion for discussion between you. It's very important. And I say also, I want to say, this is the reason why I'm telling during recording, that some questions in the final theoretical exam that you will do are of this kind, just to sketch the solution for one of exercises like the one you did yesterday, and we will today, and also in the next weeks. So take them seriously. And the other thing I want to say, I need feedbacks from you. So I have already feedbacks because you send me questions by mail, or now we have started to put on the forum, so the public questions. And I always say, don't be timid, ask in public. And so I have some feedbacks. I have now the sentiment on which is the how you understand the topics of the course and what are the difficulties. And I keep on asking you to send me solutions, even partial solutions, for the exercises, coding exercises, and we will publish or directly publish in the forum. Very soon you will have a solution that one of you had decided to send me. And so this is very important, not only because you share your experience and I can make comments on the solutions you provided, but also because I have a feedback. So I know the situation of the class. This is very important. In real classes and physical classes altogether is different. So the only feedback that the teacher can have is the output of your efforts. And also, this is true also for the sketches I'm asking you to do for the general solutions in drawings, in sketches, in notes written, doesn't matter, but I want them, because it's necessary for me to know if I succeeded in transferring to you the knowledge of the components, of the theoretical components on how to build a complex system. So please do the same, not only with coding, with codes you developed, but also with those sketches. If you don't want to publish directly, please send me just some few ideas, and I will publish. And so I want to, in any case, to publish the possible solutions of the exercises we are doing now. Okay, that's finished. But This is what just to discuss how important is also this level of solving problems, not only coding, that is the effective level, of course, but the theoretical, the synthetic moment in which you synthesize a solution is very, very important. And I repeat myself, will be part of the exam, the final exam. So that's another reason for asking you to send me feedback on your perception of this kind of problem. Okay, go back to the, as always, interrupt me anytime, no problem, for um, questions or other things that you deem relevant. And I go back to the socket slides. Socket slides are okay. I'm sorry, I did something. Back, go back. Okay, can you see the slides?
Yes, yes, we can see the slides.
Yes, Professor.
But I have, problem is that, the problem is that I can't go, no, there is something that doesn't work, sorry. Return. Let me, okay, now it should work. I'm sorry, it was a full screen, so I couldn't have all the elements for in particular the lift on the left side to go up and down. So good. We have seen yesterday the definition of socket, so I don't return on this concept. The concept of IP address and port number. Many of you already know what is this terminology in network terminology, but I will repeat that for those of you that are newbies in that this is an IP number that is in a standard that is called IP version 4. That is the classical version, the first standard 50 years ago in internet protocols means internet protocol version 4 is 32 bits. We will remain and we will use the IP version 4. That is the simplest. A new version is the version 6 that has many more numbers for designing addresses. But so far there is no, in the world, there is no strict need for using the IP version 6 with more addresses because of the sub networks and so on. So we will stay in this. Usually is written as 4 octets, so 4 numbers of 8 bits. and usually they are written in decimal form. So 35 is just 35, 35 decimals, so 35, even if it is an 8-bit number. So, for example, this is a decimal, of course, a decimal number, not base 2 or base 8 nor base 16. So you say this is specified this this address. This address usually is determined. You can discuss the number with your provider or your organization, but it is assigned to you externally, and you have. And that's one of the number, well, the most important number that you must keep fixed in your virtual machine on the cloud. The reason why will be clear going on, but if you, when we will make your personal virtual machine to talk with another personal virtual machine of another student or with mine, they must know their fixed public IP addresses, so they must not change. And this is a choice that you do while dimensioning your virtual machine. The port number is a 16-bit number, and you decide the port number. You choose the port number. The port number defines inside the same machine which is the process that reacts to the socket connection. Usually is called the service or protocol or port, because if you write a different process that was the way of communicating with other processes is different, so you're defined a protocol, your personal protocol. This protocol is connected to the number you choose here. So we have seen that first we have to create a socket, and the only relevant thing in our exercise and in normal coding is the domain type of the socket, and moreover the stream diagram. We will have more information on that. A protocol, low-level protocol used by networking method is may differ, but usually you say 0 and use the default method. Domains. This is the one that we normally use in networking. These are symbols in POSIX, so you can use those symbols that correspond to numbers directly to define the kind of domain. You see here IP version 4, that means 32 bits, addresses, and this is the IP version 6, that is the 120 bits addresses. In any case, modern machines, modern smartphones and everything is able to manage also this kind of address. Older machines do not, but normally in using internet, normally we use this domain. And that's for making process communicate in the net, in internet, in general, or in the local network everywhere. Also in an automation local network. There is also the possibility of deciding the Unix domain, but is mainly historical domain. In this case, you cannot go outside the machine. You stay in a single host. And the address in this case is not the Internet Protocol IP address, is just the file system path name. But I telling you just to be complete, but it's very rare to use that. Well, this is a synopsis of all that. We don't mind. This is just to have an idea, just if this idea says something to you, that in that case we are on the network. So the socket is an interface. In this case, it's the opposite. And also, this is your machine. The process as a socket that interfaces the cyber world of your machine, in which processes are identified by ID and communication channels are identified by file descriptors, interfaces with the other world, that is the net systems, in which there are several level of components. So the physical level has to do with the cables and the wiring, the modulation systems for the wireless communications, and so on and so on. And the packets of information, I told you yesterday, information is transferred in packets like blocks on a hard disk, are managed by the layer that in the network is called the transport, and transport layer knows addresses and the way of routing and delivering packets and so on. So it's an interface. A socket is just interfacing the internal world, cyber world, and of your concurrent programs with the external network, communication network. There's no relevance between for practical use, but this explains why there are terms and concepts that are a bit different from the usual internal concepts in the kernel, because they refer directly to the network terminology. This is just examples and synopsis of the port numbers. The lowest port numbers are reserved for basic services. They are called in jargon well-known services. They're well-known because they were decided, many of those services have been decided, and their port numbers have been decided 50 years ago. So 50 or 60 years ago, in particular, lowest number. And you can see here, for example, some of those services and processes are not so in common use today. Telnet is just to log in and in a different machine in the network, just like you were working on your shell. Today we use the secure shell that has the well-known 22 port. There is a service for, and you will use in probably, I'm sure you will use in your virtual machine on the cloud. So when you connect to a shell, remote shell, can be on the cloud, but also on another PC connected to the network, you use the 22 port. Another well-known port is 80. Popular port is 80. That is the TTP, I have to correct, is the web, the World Wide Web by Tim Berners-Lee, and so on. Um, other, so even if you can, these are free to use, it's a good practice not to use those ports because they are registered. So there is a de facto standard so that uh, processes, as to say, software applications and programs that you can install in your machine use a certain port, a registered port. So even if you can use them freely, the good idea is to use this segment that is completely free, and the authority guarantees that there will be no registration. Ephemeral means that sometimes when when you have a process on a machine, and here is the network. For example, during the connection, P1 can decide to establish a new connection using a new port. A temporary port, just for another communication with P2 or another process, maybe a P2's son, for example, or something else. This new connection, that is a temporary connection that is also in a process for messaging. The idea is if it is temporary, so its life is only during a session of communication and then is deleted. This is called ephemeral. And the de facto standard is that when a process needs to open during execution new port, that will be deleted, will be closed. So, well, no more in use after the communication has ended. You choose one of those addresses randomly, for example, and then you delete. And this in jargon is called ephemeral. So I wanted just to let you know that. This drawing shows you that I shown yesterday. So there could be on a server with the same address more than one or many servers, so many sockets connected to different ports. And so the client in that case identifies the server, but identifies the process to talk with using the port. This is conceptual, but very important, even if I'm probably not sure in your assignment you will use only TCP. I'm not sure, maybe use UDP. It's very, very simple. I will show you. TCP and UDP are two terms in the networking world. Two basic protocols in internet. 60 years ago they were defined, and they are absolutely in use. The first one, well, there's no first and second. Probably the most common is TCP. It is called transmission control, and this is a user datagram. Datagram is the word was taken for recalling the telegram term. Is a telegram of data. sent through the internet, while the TCP is a well, socket diagram. Well, these are reversed. There's a oh, mistake. I will change the stream. Usually is the datagram. The transmission control protocol means that not only you send data, so they are datagram in general, but you also have to control the transmission so that you are sure that the transmission is successful. There are other possibility, but this is in the Unix, typical of the Unix system, are more direct transmission, communication, more efficient, but out of standard, so is rarely used. This probably the most important protocol is a byte stream. Packet switching network is a term of the networking that means that, like in a telephone network, as soon as you've selected the number of the party you are calling, a circuit is established, so your telephone is connected. And several years ago, it was physically connected to the other telephone with a wire across the country, across the sea, and across the nations and so on. There was a physical wiring. So your analogical voice was just a voltage on the line connected to the receiver. Today is not so, because all telephone networks are digital networks. But the idea of you have a circuit, and in internet, all packets, so the single chunks of information that flow and are delivered are get the target using a virtual circuit connecting the source and the destination. The switching as recalls the fact that during the path between Genova in Italy and Saigon in Thailand, several steps as to switch and decide which is the way. Doesn't matter. Just to say why this strange name, and that refers to network terminology. Reliable is the important, the relevant keyword. All packets, since when you send a stream of data, 1 megabyte of data, this is cut in packets, probably 1 kilobyte, 2 kilobyte, 4 kilobytes, depends on the network, is not predetermined. All packets will arrive at destination, but they will arrive all in order, even if some packet follows a different path and takes a longer time with respect to some other packets. All packets will arrive, no packets will be duplicated. So the communication is completely reliable. You can trust in that. Flow control means that the protocol takes care of this. To all packets, they must arrive, not duplicate, and so on. You have two channels, so this is very important. Both ends, just like an unnamed pipe, both sides can send bytes to each other using FD, using a file descriptor, and so similar to pipe. The connect is called connection oriented in the sense that, like two party phone calls. I select the number of the other party, and we have a connection. Or a registered mail. When you send a mail and this register, you're sure that you will deliver the message is delivered, and you have the receipt of the reception. That's the TCP method. The mechanism is so just like similar to a pipe. The two sockets, two file descriptors, are connected with the bidirectional buffer. And also you have error like the errors, if it is the case, just exactly the same error for pipes, like sick pipe, that is a signal that is raised when a pipe is broken. The datagram socket, the UDP, is in jargon is called message oriented, in the sense that you have no control on the message. So you simply know that the message has been sent. The metaphor is the digital television or radio, radio broadcasting. Broadcasting is the term probably. Broadcasting. So you send, but you don't know who receives what. No acknowledgement, no retransmissions, and so it is unreliable. Packets sent by the transmitter can be received out of order since they are numbered, so that the message can be recomposed, but you may receive in different order. There can be loss of packets and can be, in some cases, duplicated. It's called connectionless, since the connection is the control that guarantees that everything you send is received and the sender knows that has been received. It seemed to be useless, but is very important because it's more efficient. In the case of TCP, the so-called overload in transmission is big. The payload, so the amount of effective information that is transmitted, is little with respect to the all information that the system must manage to guarantee that the transmission is reliable. All controls for handshaking between transmitter and receiver and so on. In datagram, the overload is very tiny, and so is efficient. In case that you know that the network does not introduce many errors, so you can rely on what you receive, even if it is not guaranteed, not formally guaranteed to be reliable, it's a very good system because it's very efficient. And also in cases you cannot take, the transmitter cannot take care of all receivers, like broadcasting in particular. You have just one transmitter and millions of receivers. You cannot wait for the acknowledgement by all receivers singularly, and is widely used in many situations like this, but also in automation and for example in remote control, in which you need very fast response, good use of bandwidth, and so it is important. Well, typical situation: server client. The server client is typical of TCP. And in this case, the server is passive and client is active. Server creates the socket and waits. So opens a socket. So client has a plug and plugs into the server socket. And as soon as this plugging is completed, they can start to communicate each other. Usually, a policy for communication is that the client sends first a question to the server or demanding something, and server responds, replies, and so on, like in HTTP, like using the web protocol. The browser is a client, connects to the socket of the web server and asks for a page, and the web server replies and transfers a page, and so on. This is a simple exchange. This kind of rule is a protocol that is called application level. Application is your browser and the web server, two applications. And in HTTP, that is a protocol, a higher level protocol, the application level protocol is a very simple protocol that simply is a dialogue in which the client asks and the web server answers, sending a page. And they do in not simultaneously. They alternate themselves. So that's an image of what happens and what you must do in your program. First, the server asks the POSIX to give it a socket. Give me a socket. I open a socket. Then I have two other operations. Bind, that will give you the file descriptor, and listen. Listen means, okay, the server goes into waiting state, simply waiting for just like reading from a pipe and waiting for the first data to be read. Accept is the activation of the connection, and so this time the server is passively ready. From the client side, you have the socket, and simply connect. In connecting, now we will analyze very simply, because it's simple to understand. What is specified in connect, you specify which is the address of the server. So you're connecting to this, and as soon as you're ready, you send some data to the server, and so the server receives using or a special a primitive on the file descriptor, but is or you can use the normal read like from a pipe or a regular file. You can send, and symmetrically you can send and receive. As soon as you've finished, if you close, the server may close or start again with accepting other sockets, other message on the socket. Okay, I'm going slowly just because I know that some of you are already familiar with this concept in networking and so on, and some of you are not. The functions for communicating are those. Connect is the is related to the address and port. Send to is similar to write, or you can use directly write. And the function to pass address from operating system to the user is this one. So in the example, in our web, there are already codes with many, many comments and descriptions, step by step, of a session of the client-server communication, and simply the read and write are used. We will see which are the differences, are very teeny. There are some data to be described. I would like to skip now because there are details and they're boring if seen on the screen. You can read on the slide and in the included document. But in any case, there is a structure that holds the address. We will refer only with the IP version 4 addresses, the 32-bit addresses. And you see there, you must fill all the fields, but in that case, you know that this is the, in this example, use the internet, TCP, and IP version 4. The last is for historical reason. There is also a string, but is unused, so you can leave zeroed from beginning. So you don't need much data to fill all, and in general, they are already defined. The first, and well, I think that we can rest just after having a look to the main primitives, but just not going into details. First, you have to say, to ask the system for a socket. This has the parameters. Then you bind, assign a protocol name to the socket. Then you listen, and this simply says, okay, the socket is ready. I switch on the socket. The file descriptor is returned directly by the first one. So the socket, I forgot to say, to quote the fact that socket returns a file descriptor, but you have to activate the file descriptor with the bind, connecting the protocol you want to that socket. You switch the state of the server with listen, and finally you accept. So you wait for the connection. And after doing that, you can read and write. At the end, you close the socket, and close the socket file descriptors is just like closing a file, any file descriptors, with including also errors and so on. So after this preliminary part, this is the same slide, the same drawing, but we are now in the main loop of transmission and receiving. So the preliminary part from the client and the client side is just socket having a file descriptor, You connect, send, receive, and so on. The connect is the opposite of the opposite is the dual to listen, in the sense that connects the server, sending the address, and that's finished. And the main loop is just receiving and sending. But in general, it's simpler to use read and write. These are absolutely simple to read and write. The only difference is our flags. So if you decide to use the receive and send, you have additional information that are typical of networking. So they are not in use when for file descriptors in the single machine, like using pipes or a real file. You can say, for example, that you have a non-blocking read-write, other information that is related to networking, so not relevant from our point of view. For a more specific control in networking, not in the logic of the concurrent process or concurrent program, you may use the flags that are control some specific side. The most important, probably the most important flag is non-blocking. If you decide to non-blocking send, well, there are, in any case, we skip now, not in this course. This is just a more detailed information. This is the UDP session. You will see what we will see afterwards. So very quickly, we have an idea on what socket communication between processes in the network implies. From the programming point of view, you need a prefix of with the socket, bind, accept, listen, accept, and so on. In some cases, if you use a higher level language, programming language, or object programming language like Java, C++, Python, or something like that, maybe you have classes that already include and hide the several steps that we have detailed. I want that in your exercise, you are aware of the different steps involved. So I want that you use the all the system calls we have described. I'm showing you that just before a few minutes rest, that in the tutorial and examples part here, there are several documents. This one, socket new, well, the name is my personal classification of documents versions, is a paper or as a booklet that the simplification of the original booklet by a Professor Ingalls that I passed away several years ago. That I met him many years ago. He was a very, very good teacher. And so in this document, you will see example of communication in which almost every line is commented and explained. So just to make less tricky, since there are a large number of parameters in the in codes, but here is written every parameter which is important, which is not, and how to configure them. And you will see and that document is just a description exactly of the code that is in this other document that you can take. If you want, you can compile, execute, modify, and copy and paste, and so on for your solutions. They are they refer just to this example because, for example, there's no UDP, no datagram transmission, and there's just one-way communication and not bi-directional. So you will be requested to change. But this is just to start, and I'm sure that using this document and reading the code and reading the system calls, using all the explanations, the detailed explanation, will be very easy to understand how to use also at the low level that I'm requiring to you, not using general libraries, classes, and so on, but exactly all system calls are requested. So you have all materials. I do not propose this week exercises of coding regarding that. We have just almost finished the comments on the slides and on the contents. I want you to solve your assignment and to also to solve the other exercise I will propose you after just a break, a 5 minutes break, okay? Good for you? So we shall have 5 minutes break, and then we start again with a problem I will propose to you. Okay, stop recording. Okay, break ended. We can start. And now, like we did yesterday, I will ask you to solve a problem, to sketch the solution for a problem. And I will show you the problem. Where I have to find the problem, my problem. La, 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 la. Just a while. Maybe you remember the drawing regarding the mobile robot. Okay. Okay. Found it. Okay. Can you see the perfect and professional drawing?
Absolutely, yes.
Fantastic. It was presented in the second week, I remember. But I know that in the Professor Recruito's course, this is expanded using ROS. Well, why this? I'll remind you the components. This is the central component, which is a shared memory or common memory. Is not shared. We will see in the last part of the course also sharing, how to share a memory between processes. But now this is a memory owned by a process. It's a picture of the environment with so it's a two-dimensional picture. The process, so you must, the aim of the exercise is how to uh, to describe how this process is made. This process manages this memory, maybe an array, a very big array, but many other processes can communicate and ask to, just like it were a real shared memory or a blackboard. So for example, this was the laser scanner and this the GPS. So this is a process that may be called localization. A process that continuously using also information coming from the lower level, the control of the wheels, wants to compute where the robot is. This is a process, the alarm or emergency. If you touch an obstacle or if you push the alarm button, you immediately want to stop the system. This is the odometry. That's trying to understand which are the movement of the mobile robot, just counting the turns, how the wheels rotates, and is connected to a process that is a control of the wheels, and it also has to take into account where is the position of the robot. So all these, and this of course the planner, the trajectory of the motion planner, that asks the robot to generate a trajectory moving on the environment, basing on the map of the obstacles and position of goal and so on, position of the robot. And also this is the general graphic interface by which an operator decides which commands and which is the goal of the action. So you see that this is the central one, just another circle. This is the central data structure that every process has to access by asking to write or to read. In principle, every process may do that, but of course this data structure is managed by one process. So how to design this and which primitive to use, not only considering how to make all processes to access for reading and writing, but also some kinds of priority or even rough priorities, maybe at two levels. For example, emergency. So let me write priorities. Emergency. If you want to stop suddenly the robot, you cannot wait for other communication to be completed. You want to stop immediately, want to react very soon. And another priority, just to have two cases, is the graphic user interface. As to, for example, the user, the operator, may decide to stop and to change everything is going on, and so any communication must be broken. So, for example, take into account two priorities so that two of those processes may have a different level of priority. How to? So I'm asking you to describe how to design this process, which in the same machine. So we don't use sockets, but you should use pipes, should use signals, and to dimension the general structure of this. And this is a real problem, not a completely didactical problem. It is a real problem. All designers of a mobile robot just start from this, the most important component. I will put on Aula Web with this enrichment of the original drawing. Okay. Okay, just start. We have just 18 minutes to do that. I will create rooms.
May I first ask something about the exercise?
Pardon?
May I ask something about the exercise?
Yeah.
So we have to design the central process,
The central process.
Communicates its data to processes which make requests.
And to answer to questions. So there is also some protocol, how the other processes can ask to read or write some data. Mm-hmm. All processes can do that. The process must not block in any case. So there is a sort of a non-determinism, and also some two levels of priorities. The two processes I've mentioned should have the priority in acting directly on communication with the central system. Okay.
Okay. We assume that these requests arrive periodically or aperiodically.
Oh, not periodically. Not periodically.
Okay. So okay. Thank you.
Advanced sharing. Okay. Okay, we are all back. Okay. I still push you to send me some feedback. Please send me your drawings, your notes, everything is able to show me if you understand which are the problems, because in the end you will have an exam on that. And don't be timid also in this case. Remember that my drawings are so simple and funny that your drawings will be surely more professional than mine. So send me by private email, show on the forum as you like, but do something for me, please. Okay, thank you for attending the class. Wish you a good time. Do your assignment, study, and you know that on Saturday we have a meeting for those of you who want to talk. Bye-bye. Thank you very much.
Thank you. Goodbye.
Goodbye.
Bye-bye.
Thank you, Prof.
Have a nice day.
Bye.
Goodbye.